Dear students and my fellow viewers, I welcome you all. As I am discussing with you the image formation with the help of ray diagrams in case of convex lenses. So far I have discussed the five cases, the five positions where the object can be placed in case of a convex mirror. Now in this lecture I am going to discuss with you one more case from the convex lens, and we will also discuss in this lecture the concave lenses and the image formation with the help of ray diagrams by these concave lenses. Now let's go straight to our topic. Dear students, we will discuss here the case when the object is placed between focus and optical center in case of a convex lens. So when the object is placed, this is your convex lens, you need to take the object between the focus and the optical center. This is here the optical center and this is the focus of the convex lens. Here we have taken this object AB. Got it here? So from this point a ray of light strikes this convex lens and refracts from this convex lens and passes through the focus of the convex lens. Why? Because this ray of light is passing parallel to this principal axis. So the rule first says that when a ray of light passes through a convex lens and that is parallel to the principal axis, after refraction from the lens passes through its focus, so this ray will pass through its focus. Similarly, another ray of light from this point A, dear students, it passes through this lens through the optical center and it will pass through. So there will be no deviation in this ray of light. You are now well aware because you have learned about the rules. Got it here? So from this right side, it's obvious that these two rays do not meet. They do not meet at any point. So there is we can say the possibility of image formation from on this side is we can say impossible. So how can we determine, how can we detect where the image would be formed? From the back side, dear students, if we will extend these rays, if we will extend this ray and if you we will extend this ray, these two rays they meet at this point. So here at this point we will get the image of this point A. So this point is here represented by A dash. So we can name it here at A dash. So to get the full image from A dash, so this point, dear students, it can be represented here as A dash. To get the full image from this very point, we draw a perpendicular on this principal axis A dash B dash. Thus A dash B dash is here the image of the object AB, which was taken between the optical center and the focus. So dear students, in this case, when the object was placed between focus and the optical center of a convex lens, in this case the position of image, where is the position of image? It is on the same side of the lens as the object. So we can say the image is on the same side of the lens as that of the object. So in this case, what is the size of the image? Dear students, the size of image in this case is enlarged. यानी यहाँ पर जो इमेज हमें मिलती है उसका साइज बड़ा होता है, जैसा कि आप देख रहे हैं. सो व्हाट इज़ द नेचर ऑफ द इमेज? क्योंकि हियर द एरोज एक्चुअली डू नॉट मीट, सो इट्स वर्चुअल इमेज. ठीक है, एंड इट्स ऑल्सो इरेक्ट. So this was the lost case in case of convex lenses. Okay, now dear students, let's learn the rules for obtaining images formed by concave lenses. Okay, so rule number first says that in case of a concave lens, a ray of light parallel to the principal axis of the concave lens appears to be coming from the focus after refraction through the lens. This is here a convex lens. You got it here? So this xy is here the principal axis and this is the focus on the left as well as on the right side. And this is here a ray of light which is passing parallel to this principal axis. This ray of light, dear students, it passes through this lens. Okay, it refracts through this lens and it is divergent. Now if you will extend this divergent ray of light which passes through this lens on its back side, so it appears to be coming out from the focus. Rule number one says this point that a ray of light which is parallel to the principal axis of a concave lens appears to be coming from the focus after refraction through the lens. यानी ये जो रे ऑफ लाइट यहाँ से डाइवर्ज होकर इस कनकेव लेंस से निकलती है, ये हमें लगता है कि ये कहाँ से आ रही है, ये हमें फोकस से आ रही है. ठीक है, it appears to be coming out from the focus. ये आपको याद रखना है. This is here dear students rule number 1 in case of concave lenses. Now rule number 2, a ray of light passing through the optical center of the concave lens goes straight after refraction through the lens. यानी ये हम यहाँ पर principal axis है, this is concave lens here. एक ray of light जो यहाँ से आ रही है किसके थ्रू आ रही है? थ्रू द ऑप्टिकल सेंटर ऑफ दिस concave lens, it passes through. There is no deviation in this ray of light in case of a concave lens which is passing through the optical center. So here it is the same case as in case of convex lenses. Now you got here the rule number second. Now dear students, what's rule number third regarding this image formation by concave lenses? Rule number third states that a ray of light going towards the focus on another side of the concave lens becomes parallel to the principal axis after refraction through the lens. Now look at this diagram. This is here a concave lens and this is the principal axis and these are the focus on the left as well as on the right side. Here this is the incident ray of light. This is the incident ray of light. This incident ray of light, it passes through this concave mirror. Got it? So it refracts through this concave lens. But if you will trace the path of this incident ray, it actually appears to be going towards the focus. ये हमें लग रहा है कि फोक्स की तरफ जा रही है. ठीक है. तो रूल नंबर थर्ड हमें यही कहता है कि जो रे ऑफ लाइट कनकेव लेंस में किसकी तरफ जा रही हो? फोक्स की तरफ जा रही हो. ठीक है. जब वो रिफ्रैक्ट होकर उस लेंस से वापस जाती है, दैट बिकम्स पैरेलल टू दिस प्रिंसिपल एक्सिस. सो दिस इज रूल नंबर थर्ड रिगार्डिंग द इमेज फॉर्मेशन इन केस ऑफ concave lenses. Now dear students, these were the rules. Now let's try to find out the image formation by concave lenses with the help of ray diagrams. So there are only two cases. The case number first states that when object is placed at infinity, जब हमने object को कहाँ पे लिया? Infinity के ऊपर. You know the infinity, it is an unknown distance from any substance, from any lens. So infinity पर हमने इस object AB को लिया. ठीक है. This is AB here, an object which is at infinity. तो इसी तरह from this point a ray of light strikes this concave lens and it refracts through this lens. Similarly, from this point B, another ray of light strikes this concave lens and it also refracts, यानी इसके पास थ्रू से पास हो रिफ्रैक्ट हो जाती है. So basically this is a concave lens, so it will diverge. इसने इसको इस तरफ डाइवर्ज किया, इस रे को इस तरफ डाइवर्ज किया. अब यहाँ से कोई सवाल ही नहीं पैदा होता फ्रॉम द राइट साइड कि कहीं पर ये रेज आपस में मिलेंगे. लेकिन ऑन द बैक साइड जब हम इनको एक्सटेंड करते हैं, दीज टू रेज दे अपीयर टू मीट एट फोक्स. ये फोक्स पर हमें मतलब अपीयर हो रही है टू मीट. ठीक है. सो इन दिस केस व्हेन ऑब्जेक्ट इज प्लेस्ड एट इंफिनिटी इन केस ऑफ ए कनकेव लेंस, हियर द पोजीशन ऑफ द इमेज, वेयर इज द पोजीशन ऑफ द इमेज? इट इज एट द फोक्स. तो पोजीशन ऑफ द इमेज कहाँ पर हमें मिलती है? एट द फोक्स. एंड व्हाट इज द साइज ऑफ द इमेज? एज इट्स एविडेंट फ्रॉम दिस फिगर, from this diagram, it is very small, very small. So we can say size of the image is highly diminished, or we can say it's of the point size image. Now what is the nature of the image? As it is, so this is virtual and erect because light is actually do not meet here, so it's virtual and erect. So nature of the image in concave lens is virtual and erect. Now this is case number first is okay. Now let's try to understand case number second. Dear students, when object is placed between infinity and optical center, अब हमारे पास एक पोजीशन रहती है जब हमने ऑब्जेक्ट को लेना है between the optical center and the infinity, यानी infinity मान लीजिए आप यहाँ से और कहाँ? ऑप्टिकल सेंटर के बीच में. So here AB is an object. ठीक है. तो इसी तरह हम फ्रॉम पॉइंट ए रे ऑफ लाइट जो इस पर स्ट्राइक करेगी कनकेव लेंस पे, इट विल डाइवर्ज, यहाँ से डाइवर्ज हो जाएगी. ठीक है. इसी तरह अनदर रे ऑफ लाइट पासिंग थ्रू द ऑप्टिकल सेंटर, सो इट विल पास थ्रू, इट विल नॉट डिवेट. लेकिन जब हम इस रे को जो है ऐसे इसको पीछे से एक्सटेंड करेंगे और यहाँ से जो रे जा रही थी ऑप्टिकल सेंटर के थ्रू, तो ये यहाँ पर हम कहेंगे यहाँ पर इस पॉइंट पर ये मीट कर रहा है. ये पॉइंट हमें किसके बीच में है? तो जिस पॉइंट पर ये मीट कर रहे हैं यहाँ पर, ये अपियर टू मीट हो रहे हैं, ये पॉइंट हमें क्या मिलेगा? यहाँ पर हमें इस ए का ए डैश मिलेगा. सो टू गेट द फुल इमेज वी विल ड्रॉ द परपेंडिकुलर. सो ए डैश बी डैश इज हियर द इमेज. अब यहाँ पर इन दिस केस व्हेन द ऑब्जेक्ट इज प्लेस्ड बिटवीन इन्फिनिटी एंड ऑप्टिकल सेंटर, वेयर इज द पोजीशन ऑफ द इमेज? ये ऑप्टिकल सेंटर है. ठीक है. और ये फोकस है. तो हम यहाँ पर ये कह सकते हैं इन दिस केस द पोजीशन ऑफ द इमेज, हाँ, तो इमेज हमें कहाँ पर मिली? बिटवीन फोक्स, यानी बिटवीन फोक्स F1 एंड ऑप्टिकल सेंटर. फोक्स F1 और ऑप्टिकल सेंटर के दरमियान मिली. एंड द साइज ऑफ द इमेज इन दिस केस, यानी यहाँ पर अगर हम साइज ऑफ द इमेज जोड़ने की कोशिश करें तो साइज ऑफ द इमेज भी छोटा है, तो हम कह सकते हैं साइज ऑफ द इमेज इज हियर डिमिनिशन. एंड नेचर ऑफ द इमेज जैसा कि क्लियर है फ्रॉम द डायग्राम, इट्स वर्चुअल एंड डायरेक्ट. So dear students, this is all about the concave lenses and the image formation with the help of ray diagrams. In the next lecture, I am going to discuss with you the relevant topics. Till then, Allah Hafiz.